Often, even later questions in the Senior Maths Challenge, you can essentially attempt with like earlier school mathematics. It's just, really hard versions of Pythagoras' theorem, maybe some exact trig, that sort of thing. But sometimes questions come along that really do mean that you have to have studied A-level maths. Um, First year A-level maths, to be fair, but like, you might not have even got to this point in the syllabus if you're doing the first year content. Um, so I'm going to talk through this in terms of the A-level maths, and then I'm going to talk a little bit about how you could use some other methods, but I did the A-level maths method. So first up, this is essentially a hidden cubic. It's a cubic in sine x. So I could let u equal sine x. Do you know what? Sorry, it should be capital X the way they've done it. So that's going to give me 1 plus 2u minus 4u squared, because if u is sine x, then u squared is sine x all squared, which is what we mean when we write down sine squared x. And then similar for cubed, so 8u cubed equals 0. Now straight away, I'm going to change all the signs, basically multiply through by minus 1, so 8u cubed plus 4u squared minus 2u minus 1 equals 0. Now, to solve a cubic, methods involve trying to find a value of u that will actually give you 0 on the right-hand side, and you then use the factor theorem. So you might think, right, I'm going to try u equals 1, and then we'd get 8 plus 4 minus 2 minus 1. There's no way that's going to equal 0. Okay, it's got to be minus 1. So then we get minus 8 plus 4 plus 2 minus 1. And actually, that is not 0 either. Normally, I tell people, right, it's got to be one of those factors. It's just got to be to make it work. But actually, in this case, it doesn't. Now, actually, you have a bit of a hint in this question. We know it's a trig question, and there are some exact values of trig to be aware of, and that is things like sine 30 is a half, and there's root 3 over 2 and things like that. But what I'm trying to say, some ways, is like maybe the solution is something like a half, and that would actually give rise to a factor like 2x minus 1, which is what you get if you substitute a half in for u. That's, I think, what makes this question particularly difficult, like realizing that, in fact, yeah, 1 and minus 1 don't work. Other integers aren't going to work because, well, they're very unlikely to work because, you normally multiply your numbers out in your bracket to give you the number at the end, which in this case is minus 1. So we're going to go with a half and we're going to see what happens. So 8 times a half cubed plus 4 times a half squared minus 2 times a half minus 1. Right, and now this is going to equal 1, and then this is going to be half squared is a quarter, so plus another 1. But then we're minusing 1 and minusing 1, we are going to get 0. Brilliant. And by factor theorem, I'm not going to write that down, but by factor theorem, 2x minus 1 is a factor. I'm going to continue to use these A-level methods. I will show you a method at the end that the answers talk about, but this is the approach I'm using. And then there's more than one way of doing this. You might like just write your factor out and see if you can figure out what will go in the bracket. There's methods to do that. For example, sorry, I'm using x, aren't I? But I should be working in terms of u. Apologies. We just normally use x. So if this is going to factorize into bracket, it's got to be 4u squared. It's got to be a plus 1 here. And you can kind of figure out what has to go here by looking at the other terms. And I might actually just do it this way to show you. So, right, we've got the minus 1. I need a minus 4u squared. So what else how is that going to work? Minus 4u squared. Oh no, sorry, I need a plus 4u squared. So I somehow need to get another plus 4u squared. So that's going to be, I need a 4u here. Confuse myself a minute. So yeah, that's what I'm going to get. Um, now that's, if you're not familiar with that, and to be honest, I've not done that for a long time, then a much better way is to do polynomial division. Of course, I'm assuming that you've like done all these topics before, otherwise this isn't going to make a whole lot of sense. So 8, this is like a version similar to long division to divide polynomials. Okay, so 8u cubed divided by 2u is 4u squared. We then multiply back through the 4u squared by 2u minus 1, give 8u cubed minus 4u squared. And then subtract. We're going to get 8u squared minus, bring the 2u down. Then it's going to be plus 4u, 8u squared minus 4u, subtract. Going to get 2u minus 1, and we're going to get a plus 1. Hey, the same thing as we did above. Multiply through, and we get this remainder of 0. Okay, so that means we've got 2u minus 1 times something. And I'm now going to try and factorize this. And actually, it factorizes quite quickly to 2u plus 1 squared. Okay, that will work out equals 0. And we've actually got an equation now to solve. Okay, but look at all that stuff we had to do to get there. Now the answers, not very helpfully, just kind of do this. Like I would never have thought to do this. I suppose if you learn how to factorize quadratics, there's like a way you can do it where you bring out factors and then bring it together. Like maybe you could do it this way, but they're acting as if this is just obvious. Yeah, to factorize the 4x squared out. Notice the common factor of 1 plus 2x, and then yeah, get to here, which is essentially the same as what I've done there. Their x is sine capital X instead of I'm using u. You know, you might be happy with that, but maybe you're happier with the way I did it. It's just the way I did it is I had to find a factor and kind of, you know, I don't think that is sort of obvious unless you start thinking about the trig. But I suppose that's what you've got to do after trying, you know, 1 and minus 1, is to try some fractions. Okay, so we're actually nearly there now because we've got u equals a half or minus a half. And remember, that is sine x. So sine x is a half, or sine x is equal to minus a half. And because we are looking between 0 and 360, actually, you might know we're going to get 2 solutions from this one, and we're going to get 2 solutions from this one, and they're going to be different. So the answer's got to be 4. Let's just complete the problem though and see what we actually get. So sine x is equal to a half. Right, I'm actually going to draw the sine graph because that's how I know it's 2. I'm kind of assuming that you've done this topic already, but this is a sine x graph. So we're interested in where sine x is equal to 0. So it's there and there. In fact, the first one is 30. That's an exact value to become familiar with. And because this is 180, the second one by symmetry is 150. You might use CAST diagrams to get other solutions, in which case you'd still get 150. And then with the other one, it's minus a half, so it's down here. And again, we can kind of use symmetry because it's going to be like, it's going to be 30 away from here now, so it's going to be 210. I don't learn those values, I just kind of learn that I can get them. And then it's going to be 30 away from 360, so it's going to be 330. So those are our 4 solutions. That is the question solved. Good question, but yeah, pretty tough if you're not familiar with these things already. And even if you are, it's stuff like this or their solution here that can really trip you up. Okay, well done.